Alrighty, we're going to go ahead and find the area of this triangle. We're going to use two different methods so that we can see if we get the same answer using each method. The first method, we're going to find the height of the triangle and the base of the triangle, and then we're going to do 1/2 base times height, or base times height divided by 2. And the other way, we're going to sort of cut the triangle out from a larger shape. Okay, show how that works later on. So first, finding the base and height. Now, the base and height of the triangle could be, there's 3 different options. This could be the base, and the height could be measured down to here. Now, this could be the base, and my height is measured here. Or, turn it all the way around. This could be the base, and my height is measured here. And any of those will work, but it's possible that one of them will be easier than the others. And the reason why one might be easier is because we have to find the length of the base, what we're interested in is if I draw that height line. Remember, the height line, the altitude, has to be perpendicular to the base. And if it happens to meet the base at a nice place, like whole number coordinates, then it's going to be easy to find its height, because it'll just be the distance from one lattice point to another, which is relatively easy to do. It could be, on the other hand, that the height intersects the base at some insane, crazy fraction, and that'll make things more difficult to find that height, how far it is down to the base. So let's take a look here. The slope here from A to B, it goes from, let's see, 5 to 2, that's down 3, and 1 to 11, that's forward, or 1 to 12 is forward 11. So down 3, I'll write this down, down 3, forward 11. So the negative reciprocal of that slope would be 11/3 positive, right? So up 11 over 3. So if I were to draw that altitude here, we'd start at the point 13.9, and we would go down 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and over 3 to here. Right? And I'm pretty certain that this line is not going to connect with the base at nice whole number coordinates. It's not going to happen. So we're not going to pick that one. So what if this is the base and I draw the altitude down to here? Well, let's see. This base, we go from 12 to 13 and 2 to 9, so our slope is 7 over 1. So the negative reciprocal of that would be negative 1/7, which means we go 1, 2, 3, 4, 5, 6, 7, down 1. 1, 2, 3, 4, 5, 6, 7, down 1. So we're going to cross somewhere around here. It's not going to be a whole number coordinates. It's going to be ugly. So let's try this one. Maybe we'll get lucky here. From 1 to 13, that's 12. And from 5 to 9, that's 4, which is 1/3. So our slope will be -3, which means we'd be going down 3 over 1, down 3 over 1, but going the opposite direction. It'd be up 3 over 1, up 3 over 1, and ooh, this looks promising. Let's look here. Over 3 up 1, over 3 up 1, over 3 up 1. We land right here. Down 3 over 1, down 3 over 1. So it works. So we got lucky. Let's take a look here. So it just so happens that the height of the triangle measured at this point intersects the base at whole number coordinates. Let's see what are those whole number coordinates. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 10, 8. There we go. So now we'll just have to find this distance and that distance and plug them into our formula. So let's see. We'll call this point A, B, call that C. We'll call this D. All right, so let's see. dB squared equals, let's see, from 1, 2, 3, 4, 5, 6. 6 squared plus 2 squared That's 36, and 4 is 40. And so dB equals square root of 40. Now the distance from A to C. So let's go over. All right, so I've got AC squared is 1, 2, 3, 4. 4 squared plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I kind of already did that. 12 squared. Okay, so let's see. AC squared, that's 16, and 144, it's early in the morning and I'm going to make mistakes. So 144 plus 16 is 160. So AC is equal to the square root of 160. So use our formula, which is area equals base times height over 2. So our base is square root of 160. Our height is square root of 40 over 2. 160 times 40 is 6,400. So square root of 6,400 over 2. And it just turns out that 6,400 is 80 squared. So square root of 6,400 is 80, 40 square units. Okay. So let's now take a look at our same triangle, and we're going to find its area using a slightly different method. So now, let's review this method real quick first. So first, I had to find a base and height that I could use. Now, I could have used any base, any side as the base, and calculated the height. But I did some poking around, and I found that since I have to find the length of the height, or the height of the triangle, it would be nice if the point where the altitude intersects the base is whole number coordinates. That would be nice. So I kind of poked around a bit to see if that happens with any of the three altitudes, and it happened with this one. So to find the slope of the altitude, I just took the slope of the opposite side, found its negative reciprocal, and then I just kind of used that to count spaces from here, or I could have done from here or from here. But if I had done it from one of the other points, I'd have to set up equations and find points of intersection, and very complicated. Here, it just turned out to be nice and simple. I just count spaces and bam, I landed right there. All right. So then once I find that point of intersection, I had to find the height of the triangle, so the distance from the point B to where it intersects AC, that distance there. Just use Pythagorean theorem. Nice whole number coordinates, made it fairly easy. Then I had to find the length of the base. Right? Again, whole number coordinates, so not too terrible using Pythagorean theorem. And then I've got base, I've got height. I plug them into the formula, and there we go. A little simplification. Now remember, when you're multiplying square roots together, you just multiply the two numbers together and put them under a single square root bracket. And this happened to be a whole number, so test for that. Now, the second method, what we're going to do is, I am going to sort of encase this entire triangle in a big rectangle. So, entire triangle in a big rectangle. And the area of this overall rectangle is just the base times height, so area of rectangle, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 1, 2, 3, 4, 5, 6, 7. And that is, what, 84 square units. Okay. Now we're just going to calculate the area of these three triangles and just subtract them from the area of the overall rectangle. And these are going to be fairly easy to calculate because they're just right triangles right along the grid lines. So let's see. 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's see, 4 times 12 is 48 divided by 2 is 24 units squared. 1, 2, 3 by 1, 2, well, it's 12. No, it's not 12. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 3 times 11 is 33. So 33 over 2 units squared. And over here it's 1 by 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So the area of that little one is 7 over 2 units squared. So I just have to add these three up and subtract them from 84. So area of triangle is the 84 units of the big rectangle minus the sum of, see, 24, 33 halves, and 7 halves, the areas of the three small, what you call, triangles. So let's see, 84 minus, let's see, 33 halves and 7 halves is 40 halves, that's 20, and 20 and 24 is 44. And 84 minus 44 is 40. Which is the same answer as we got using the other method. Again, this method just box the triangle in, making it into a big rectangle. And then we find the area of that big rectangle, which is relatively easy. And then we just have to find the areas of these three small triangles along the outside and just subtract them from the overall area, and whatever's left will be the triangle in the center, which I think ultimately is probably a little, I don't know if it's more work or less work, I don't know. But two different methods which arrive at the same answer, giving us some confidence that we've done it correctly.